So we actually are going to be in the new lesson, and this is going to be lesson 1-4, and this is going to be powers of monomials. So that's the title that your book has. So basically what we're going to do is you're going to fill in the chart along with me, and then there'll be an opportunity for you to cut it out and glue it in. And then we're going to have some examples. So today's date is 10/7. That needs to be part of your notes as well. Powers of monomials. So I'm going to kind of replicate the chart. So this part you don't have to copy in because you've got the paper right in front of you. So you're going to be doing your work on that paper. So the chart says the exponent, properties, the power rule. And when we first started taking notes last Friday, what we said is power means two things. Power means a base with an exponent is called a power. The exponent itself is also called a power. So you'll hear me say power to the power, and that's what I'm talking about. Tell you we're not cutting out right now. Okay, you got to follow directions. So we have several columns, problem to simplify. Then you have the first repeated multiplication. Again, you're not writing this because you've got the chart. Then you've got the second repeated multiplication. Actually, this one has to be a little longer. And then you get the power in the A to C form. So the first one they gave us was the quantity 2 squared cubed. So what this is telling us is we're going to get 2 squared times 2 squared times 2 squared. So we get 3 of them. But what does 2 squared mean? It means 2 times 2. So each one of those gets written out as 2 times 2. And then we count up how many 2's altogether, and there were 6. So that's the first one that was given to you. Next one. This is the one where you guys are going to start. We have 5 cubed, and we want to take it to the 4th power. Okay, 5 cubed, and we want to take it to the 4th power. So how many 5 cubes am I going to write in this second column? How many? 4. So we got 5 cubed times 5 cubed times 5 cubed times 5 cubed. So everybody's doing this. And then for each 5 cubed, how many 5s do I write? How many? 3. So here's for the first one. That's the first. And then we got the second one. And here's the third one. And here's the 4th one. Holy smokes. So then I got to count how many 5s that is altogether. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, this is going to be a pain if we have to keep drawing these things. Okay. So the next one, oh, this is weird. The next one just gives me what the answer is. So what could have my original problem look like that would have given me an answer of 7 to the 12th? Gino? So I could write it as 7 cubed to the 4th power. Okay. Could somebody give me a different way? Sam? Julie? So 7 squared to the 6th power. That would work too. Yeah, we can switch it around too, couldn't we? We could have done 7 to the 6th power squared. Okay. So, yeah, I think you guys are already kind of picking up what we could do on this one. So we have lots of options. We could have even done 7 to the 4th power cubed. All right? So I'll just pick one of them. Let's pick the 7 squared to the 6th power, so we'll pick this one here. So that would be 7 squared, 7 squared, 7 squared. There's 3, 4, 5, 6 of them. And then each 7 squared is a 7 times a 7, so there's 1, 2, 3, 4, 5, 6 of them. And again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, that was kind of interesting. I like that one. And then the next one, oh, this is interesting. It just gives us this. X to the 6 times x to the 6 times x to the 6 times x to the 6. So what would the original problem look like if I had this? Sean? Yeah, since the x to the 6 showed up 4 times, then there would be an exponent of 4 on the outside. Now, heaven knows I do not want to write out x, 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 x 4 times. That's a lot. So how many x's do you think I end up with at the very end? 24. I agree with that one. It's no. Yeah. Oh. I hear some things already that sound good. All right, let's do the next one. Was 3 to the 5th y squared, and I want to cube it. So that means I would write 3 to the 5th y squared times 3 to the 5th y squared times 3 to the 5th y squared. That looks like an 8, doesn't it? So, what do you think I'm going to have in my answer column? How many 3's do you think I'm going to have altogether? So I see 5 here, 5 more here, 5 more there. And then how many y's am I going to have? I have 2 here, 2 here, 2 here. How many is that altogether? 2 and 2 and 2 is 8. 2 and 2 and 2 is 6. Now, what's interesting is when I do the first repeated multiplication, I've actually turned it into the product rule. The product rule said, when I multiply bases that are the same base, what do I do with the exponents? What did we talk about on Monday? I would add. So I would have 2 plus 2 plus 2 is 6. 3 plus 3 plus 3 plus 3 is 12. 2 plus 2 plus 2 plus 2 plus 2 plus 2 is 12. 6 plus 6 plus 6 plus 6 is 24, and so on. Okay? So who can come up with the answer to the last one? I think I'll squeeze them in here. And we're not going to draw a picture at all because that would be total insanity. We have a to the 20th, and we're going to raise that to the 32nd power. Okay, Sam, what do you think that one is? A to the, oh my goodness, 600. Could you imagine having drawn 640 A's? That's insanity. Okay, so it sounds like, and I heard a couple people say it, you guys already came up with a rule. So let's go to that rule box, which says general rule. What are we doing when raising a power to a power? Let's see. Somebody I haven't talked to? Oh, come on, people. Jordan. Okay, what's getting multiplied, buddy? What happens to the base? Does it change? Okay. So, when raising a power to a power. So I'm going to show an example of what that would, just the highlight of it. You would have something like this. An exponent, parentheses, exponent. So when you have exponent, parentheses, exponent. When raising a power to a power, you write the base once, and multiply the powers. And now I'm in parentheses, I'm going to write the word exponents, because they're at this point interchangeable, those two words. Okay? The next box asks us to answer this question. How is this rule How is this rule different from the product rule? So that was the rule we talked about on Monday. So what did we do on Monday's product rule that we're not doing today on this power rule? How is it different? Julia E? Okay. Well, no, we only do one thing in the product rule. Yeah. So in the product rule, has you add the exponents. This power rule, we're multiplying them. It's the quotient rule that makes you subtract them, okay? And then we're going to write, the last thing was to write an algebraic rule. So using variables. For the power rule. And that would be, if I have A that's being raised to the power m, and I want to raise that power to the nth power, Cameron, Kyla, what I'm going to do is write the base once, and I'm going to multiply those exponents, okay? Now the same thing is true if I have a product inside of the parentheses, as I still am multiplying the exponents. Matt, did you write it down?
Yeah.
Okay, so you should be done with that task. What we're going to do is underneath where you just glued down your form, we're going to talk about the product, the powers of products. We talked about it again on Monday, so I want to talk about it one more time. So the power of products. And the power of products, what you saw was this. If we have a product of two numbers and we're raising to a power, we said we're going to distribute the power. To each factor. Remember, a factor is a number involved in a multiplication problem. So we would get a to the mth power times b to the mth power. But what I need you to understand is that sometimes those powers also have exponents inside. So if this problem now becomes this, where let's say you have a to the b power and b to the c power, and you want to raise the whole thing to the m power, on the a, you're going to take the two exponents and multiply them together. On the b, you're going to take the two exponents and multiply them together. And the reason why last time when we did it on Monday, whatever that outside exponent was attached to our numbers is because our numbers didn't have any other exponents other than 1. And 1 times anything is going to get you what you started with. So I want to make sure you understand that. Now we're going to do a whole bunch of examples over on the odd side. So if you guys will kind of flip over, we're going to do several different examples. And we're going to do some kind of weird looking ones to make sure that you guys have some models. Plus, again, anytime you look in the book and you see the orange little cloud that has the word tutor, that means there is a video on those examples for you to watch. Plus, you can also look at, there's a check that you can do to see how well you understand the material. All right, so let's go to the odd page for the examples, and our directions are just going to say simplify, but remember how we added that other part? In the book, they add these words, using the laws of exponents. Sounds so official. And, oops, Mr. Johnson and I talked a little bit. We're going to give you a homework sheet tomorrow that is going to incorporate all the laws we've talked about so far, and you have to practice them. What we find happens is that you're used to doing a law in isolation, but when they all show up on a quiz, all mixed up, and you have to figure out which one to use, that's when people don't do so well. So we're going to start practicing that as of tomorrow night, okay? And then we have the last two laws are Friday, and then I think we're postponing the quiz from Tuesday to Wednesday because we wanted to do 2 different days of review. One, we're going to do a review booklet, and I'm going to let you guys choose which one you want to do. And then the other one, we're going to play a game. Okay. So, first problem. I have a to the 4th power, and I want to cube it. So, what I don't want to do is to have to continue to draw this out. I don't want to have to do this. I don't want to say I have a to the 4th and it shows up 3 times. And then I really don't want to then say, well, a to the 4th means this, and a to the 4th means this, and a to the 4th means this. And then I really don't want to have to count those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What I really want to do is to use my rule. If I have 8 to the 4th power raised to the 3rd power, I'm going to write the base once. I'm going to multiply the exponents, and I get 8 to the 12th power. That's a lot simpler, right? Okay. So that's what I want to do, is I want to use this as my problem-solving strategy using my rules. All right, let's do one with some variables. K to the 7th power raised to the 5th power. What do you think the answer is? Why would you listen to somebody else? Kyler. Yeah, we'd say K to the 35th power. Remember, in powers to powers, because I have parentheses. So just reminder about this one. If I had this as a problem, what math am I being told to do with the 2 and the 3? Multiply. So anytime I have numbers on either side of parentheses, I'm multiplying. It's the same thing here. So instead, I'm not going to add, I'm going to multiply, and that's what Kyler told us. So we're going to multiply the 7 times the 5, and we get our answer of K to the 35th power. Okay, so now here comes the challenge question. I think I'm going to put it here. Brackets, 3, in parentheses, sorry, 3 squared, close the parentheses, cube that, and then outside the brackets, we're going to square that. Woo! So I'm going to take this in bite-sized pieces. Ashley, I recommend you listen instead of talking to Matt. 3 squared cubed says I have 3 squared times 3 squared times 3 squared. Three squared times 3 squared times 3 squared squared means I can distribute that squared. So what that's going to give me is 3 2 times 2 times 3 2 times 2 and then times the 3 to the 2 times 2 power. That gives me 3 to the 4th power times 3 to the 4th power times 3 to the 4th power. Alright? What can I do to the exponents when I have a multiplication problem and the bases are all the same? Sean? That's when I would end. And I get the answer of 3 to the 12th power. Now, here's my question. Could I have done that faster?
Yes.
Okay, what could I have done at the very beginning, bam, to get my answer? Okay, that's what I'm looking for here. Okay, Mackenzie, see?
Okay, so what I did was I did 3 and I multiplied the 2 first exponent, so 2 times 3, which is 6, and then I multiplied that by the exponent 2, which gives me 12.
I have grouping symbol, I have a number, an exponent, grouping symbol, grouping symbol, exponent. Anytime I have numbers on either side of a grouping symbol, it's multiplication. So if I try just multiplying them all out, wow, look at all the time it saved me. Okay, so anytime I've got a power to a power to a power, it's just one big long multiplication problem with those exponents. Antonio? Not quite yet. Okay, let's try a different problem. I want to talk about that. What if we have more than one thing inside the parentheses? How do we handle that? So I have 4p cubed and I want to raise it to the 4th power. So what did that power of product / distributive power tell us to do? Julie? Is that all it told me to do? How many different bases do I have inside of that parentheses? I have 2 bases. I got to treat them both the same. So if I'm going to multiply the p cubed by the 4, I got to do the 4 also by the 4. So this is going to give me 4 to the 4th power, and then p to the 3 times 4 power. Now, what was the exponent on the 4 to begin with? What was the exponent on the 4? I didn't see it. Yeah, so if there wasn't one, it's a 1. So you are actually multiplying 1 times 4. Now, if my directions just said simplify, I would be fine with that answer. If it asked you to evaluate, that means any number base, you'd have to tell me what it equaled. Okay? So you would have to say, well, what's 4 times 4 times 4 times 4, and then put that in front of your answer. Again, you'd have 16 squared, which would be 256. All right, let's try one more. We have negative 2m to the 7th, n to the 6th, and I want to raise that to the 5th power. And I'm going to give you guys just a minute and raise your hand when you have an answer. Okay, so what do you have as an answer to it, Juliana?
What I got was negative 2 to the 7th power, n to the 7th power, and n to the 30th power.
Okay, so m to the what power, I'm sorry?
7.
And then n to the...
30th.
Okay, so there's an answer choice. Somebody have a different answer choice. Okay, Talia.
Negative 2 to the 5th power, m to the 35th power, and
To the 30th? Okay. All right. Somebody with a slightly different answer? Matt?
I got,
Okay. Don't give me the same one. Breck? Okay. Anybody else? Okay. All the answers are incorrect, but one answer is extraordinarily close to being correct. What is the value of the front number? No. Front number.
Oh, 2. Negative 2.
-2. So how do we reveal to somebody that that number is -2 when I'm using exponents? I have to write it specifically, or it can misinterpret, and we're going to actually kind of talk about that. So Talia, since this was your answer, what could you do to fix your answer? Exactly. What we want to make sure is we're not just raising 2 to the 5th power, we're raising -2 to the 5th power. Okay? So Talia is absolutely right. And again, all she did was distribute. So she took that -2 and raised it to the 5th power. When she took m to the 7th and raised it to the 5th power, she multiplied. And then when she took n to the 6th power and raised it to the 5th power, she just multiplied. And that's how she got -2 in parentheses to the 5th power. M to the 7 times 5 is 35. 6 times 5 is 30. Okay, so that's how we do that. Now, I do want to take a small moment to talk about the difference between -2 in parentheses cubed versus -2, or actually, let's do it this way, -2 to the 4th power. And then -2 to the 4th power. Okay? So this one says multiply -2 times -2 times -2 times -2. Well, what's -2 times -2? 4. What's 4 times -2?
4.
-8. What's -8 times -2? Positive 16. Signs are the same. I'm going to get a positive. This one, I'm going to change colors on, says negative, which represents -1 times 2 to the 4th. So that's -1 times 2 times 2 times 2 times 2. How many negatives are in that problem? 1. So that means my answer will be negative. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So this is what happens when you don't use parentheses. Is it's going to change the answers, meaning it's going to change the sign. Anytime you make a sign error on a quiz or a test, you lose half points. Because 16 and -16 are not the same. And it's really important that we watch signs. Okay. So that's it for those notes. So your homework is on the board, those pages 35 through 37. The 1 through 13 odd, 20, 21, 23 through 37 odd.